All right, ladies and gentlemen, let's get into this Algebra 1 midterm review. So this is a 50-question test, and you do have the use of a graphing calculator on this test, so I might make use of that here as we kind of try to speed solve through these problems. So let's get into it. Let's see how fast we can get this done. So number 1, that's negative 3.693 minus 9.9 equals negative 13.593. That's B. Okay, here in number 2, I've got 6/7 plus negative 1 3/7. If you want to just blast this out in the calculator, it's alpha y equals enter 6/7. Right arrow plus open parentheses. Now, alpha y equals, and then go down 1 and hit enter, and you can put in your negative 1 3/7. Right arrow, make it just look just like that thing there. Ready? I see a problem. I forgot this should be a plus sign right here. Okay, so it matches, and we hit enter, and we get negative 4/7. C. Okay, number 3. So we're only 1:40 into the video. This is a good average time. Alpha y equals enter 11/6 minus alpha y equals enter 3/2. Enter 1/3. 3 is A. Number 4, we're going to simplify 4k plus 9k. You just add the coefficients, 4 plus 9, that's 13, and then it's 13k. There's nothing really to do there except think. Number 5, same thing, 10b minus 4b equals 6b. Easy. Okay, we're done with page 1, number 6. Okay, we're going to have to distribute that through the parentheses. Okay, so it's going to be negative 7 times 1 is negative 7, and negative 7 times 2n is negative 14n. So it's C. Number 7, you've got to distribute the same thing. Negative 3 times x is negative 3x, negative 3 times 4 is negative 12. So it's negative 3x minus 12a. Number 8, we're going to have to distribute twice. So in the first case, I've got negative 3k times 5, that's negative 15k. Negative 3k times 10k is negative 30k. And now I've got 9k times k, that's k squared, so plus 9k squared. And then 9k times negative 7, that's negative 63k. Combine like terms. So here I've got these k values, and I can just speed through this on the calculator. All right, we're just going to combine the coefficients of all the k terms. So it's negative 15 plus negative 30 plus negative 63. We get negative 108. Did I do that right? Maybe, maybe not. Let's see. Negative 15. Oh, I see. I see what I did wrong. So here, negative 3k times 10k is negative 30k squared. My bad. So we'll just go back and do this again. So I'll combine negative 15 and negative 63. Those are my k values, and I get negative 78k. And now I'll combine my k squared values, negative 30 and 9, and I get negative 21k squared. Okay, so it's negative 78 minus negative 21k squared. That's D. Write each as a fraction. Okay, so 21 and 4/5%. Okay, so that's equal to 21.8%. And if you didn't know that, you could go in here and put alpha y equals down 1, enter, and put 21 and 4/5, and just hit enter. Okay, and then hit math, decimal, enter, and you get 21.8. So we're supposed to write this as we're supposed to write it as a fraction. So I thought we were doing something else. So it's going to be 109 over 5. Okay, that's the percent. So hold on, before we get too far into this, maybe just maybe this is something that we should do. So 21 and 4/5%. Okay. So first turn the fraction into an improper fraction, and so we saw that that was 109 fifths percent. Okay. Now, in order to turn this percent into a decimal, you just multiply you divide the fraction by 100, which means you're going to multiply by 1 over 100. Okay, so that's going to equal 109 over 500. So that's D. Okay, number 9 is D. All right, it was a little bit tricky. Number 10, Castell and his best friend found some money in an envelope. They split the money evenly, each getting $13. How much money did they find? Well, if they split it evenly, you would just do 13 times 2, and that would equal $26. C. Number 11, solve each proportion. This is butterfly. Okay, let's use the calculator. I'm going to multiply 4 times 7, okay, and then divide by 10. 4 times 7, divide by 10, get 2.8. It's C. Number 12, ooh, another one, butterfly. I'm going to multiply 6 times 10 and divide by 5. 6 times 10, divide by 5, 12. B. This is really cool. Okay, solve each equation. 171 equals 19x. All right, you do need to take a second to write it out. Doesn't have to be a piece of art. We're just going to get x by itself, so we'll divide both sides by 19. So x equals 171 divided by 19. 9. X equals 9. C. Number 14, v minus 15 equals negative 1. Okay, so we'll add 15 to both sides. V equals, okay, and if you didn't know, it's negative 1 plus 15, 14. Well, V equals 14, and the answer is D. Okay, so now we're at 15 here. Ooh, all right. So we have A minus 2, this is getting interesting, equals negative 7 over 2. All right, so we need to add 2 to both sides. So A is going to equal negative 7 over 2 plus 2. Well, alpha y equals enter. Negative 7 over 2 plus 2 gives me negative 3 over 2. Okay, so will it change it in? Is there a way for this calculator to change this thing into like a mixed fraction? I don't know if that's possible. Maybe you just have to know that negative 3 over 2 is negative 1.5. So that would be D. Because 2 goes into 3 one time with 1 as a remainder. So it's D. All right. Number 16, evaluate each using the values given. All right, so you're looking at this and you're going to plug 4 in for X and 3 in for Y. So instead of writing y plus 6 minus x over 5, we're going to write 3 plus 6 minus 4 over 5. Okay. Alpha y equals enter. 3 plus 6 minus 4 over 5. Enter 1, d. Easy. 17. Okay, so m is 2 and p is 3. 2, open parentheses, 3 plus 2 minus 2. All right. 2, open parentheses, 3 plus 2 minus 2, close parentheses. Enter is 6. 17 is 6. We're flying through it. Oh dear. Okay. So these are not hard, guys. These are just applications of your exponent rules. So we'll apply them. Let me write it out. So we've got 2 to the negative 1 over 2 to the 3 times 2 to the 0. And all of that is raised to the power of 4. Okay, so first of all, we need to work outside in. So we have this power rule that says that I'm basically going to multiply this 4 exponent to all the other exponents inside the expression. Okay, so let's do that. So we've got, this is equal to 2 to the power of negative 1 times 4, which is negative 4, over 2 to the power of 3 times 4, which is 12, times 2 to the power of 0 times 4, which is 0, and the 0 exponent rule says anything raised to the power of 0 is 1. So if you didn't believe me, you could just raise something to the power of 0 and see that it's 1. So this is just 1 right here, okay? And again, you could have just written it 2 to the power of 0. Now, stick this whole thing in the calculator. Alpha y equals enter. 2 raised to the power of negative 4 over 2 raised to the power of 12 times 1. All right, and just to prove to you that you could have, if you didn't know that 0 exponent rule, you could have times 2 to the power of 0, okay? And that comes out to some horrible looking number. Let's see what MathFrac has to say about that. Nothing, okay? So, all right, let's just plug in answer choices and see if we find it. We might actually have to do some real work. So first, let's try the 2 to the 10th. No, that's not the same. How about 1 over 2 to the 16th? Oh, there you are. Okay, so you see when we plug 1 over 2 to the 16th into the calculator, it gave us the answer. Was the same as what we found. So it's B. That's number 18. Number 19. Okay, so here we'll do 2x times 2x squared over, and now we've got open parentheses 4x to the negative 3 close parentheses, and then all of that raised to the power of 3. Up on top, we should note that x by itself, a naked x, so to speak, has an exponent of 1. And up here, we're going to apply the product rule where we multiply the leading coefficients, and then we write x, and then we add the exponent. So that's going to be 4x cubed up on top. Over here, we have to distribute this guy right here. We have to distribute and multiply him to each term, including the 4, which, remember, has an exponent of 1. So I'm going to multiply that out. Okay. So let's see what that comes to. We're going to do 2 times 2. Okay, 2 times 2, which is 4. And then we'll do x to the 1 plus 2, which is 3. So 4x cubed over, let's see, 4 to the 3rd, because 4 to the 1 times 3 is 3, times x to the negative 3 times 3, which is the negative 9. Okay, well, now we have to apply the quotient rule here. So remember, there's a 1 right here. The quotient rule says that when we divide bases that are the same, we subtract the exponents. So I'm going to move over here with my writing, and I'll write 4 to the 1 minus 3 times x to the 3 minus negative 9. All right, well, what does that equal? Well, that's 4 to the negative 2 times 3, or times x to the 3, and then we've got 2 negatives, that's really a plus, so x to the 12th. Okay, now the negative exponent rule says that we can write 4 to the negative 2 as 1 over 4 to the 2. So let me say that again. The negative exponent rule says we can write 4 to the negative 2 as 1 over 4 squared. So now I've got 1 over 4 squared times x to the 12th over 1. All right, well, 1 times x to the 12th is just x to the 12th over 4 squared. 4 times 4 is 16. You could have put that in the calculator. So you get x to the 12th over 16, and it's D. All right, that was a tough problem. Number 20, we're going to prime power factor. Okay, so we're just going to prime factor 50 and then write it as a product of the primes. So these are my favorite problems that we ever do in mathematics, and they are so helpful when you get up in mathematics. So we break 50 down, 2 times 25, and then 5 times 5. And I can write that as the product of the primes. So that's 2 times 5 times 5. Well, 5 times 5 is 5 squared, so that's 2 times 5 squared. That's D. And then we do the same thing here for 42. 42, break it down, that's 2 times 21, and then that's 3 times 7. Okay, so that's 2 times 3 times 7. There's no simplification, so it's A. Number 22, we've got 12n. Well, let's break down the 12. So we've got here 2 times 6, and then 2 times 3. All right, so that is 2 times 2 times 3. Well, 2 times 2 is 2 squared, so that's 2 squared times 3, okay, times 3. And then we just pull this in and put it right there. So 2 squared times 3n, is there something that looks like that? Here's one. It's D. This is a 3. Okay, number 23, we've got 30a squared. So first we'll deal with the 30. That's 2 times 15. Break that down and we've got 3 times 5. So 2 times 3 times 5 times a squared. 2 times 3 times 5 times a squared is D. Love it. That was number 23. Number 24, we're asked to find the greatest common factor of each. Well, you might be able to look at this one and just get it, but there is a technique. Just prime factor each one. Okay, 2 times 9, and then 3 times 3. Prime factor this one. 2 times 18. Okay, which is, now that's 2 times 9, and that's 3 times 3. And then 45 is 3 times 15, and that's 3 times 5. Okay, so what we do is we're going to go circle all the things that are in common with all of them. Okay, so here I spy a 3 in each problem. Okay, what else do I spy in each problem? I spy another 3 in each problem. Okay, there we go. So those are the only common factors across all 3 numbers, and you just have to multiply 3 times 3 to get the GCF. So 3 times 3 equals 9. So the greatest common factor is 9. So 24 is C. All right, number 25. I love these. We get to do it all over again. 21, 14, 49. You're probably thinking that it's 7, and it probably is. Okay, but we'll just do it. 3 times 7, 2 times 7, 7 times 7. The only factor in common is a 7, so it's 7. Easy clap. All right, number 26, 15xy squared. Okay, don't get scared by this. It's 15xy squared, and then we have 40 y squared. First, let's break down the numbers. So 15 is 3 times 5, and 40 is 2 times 20, which is 2 times 10, which is 2 times 5. All right. Now we break down the xy squared. Well, that's x times y times y. And over here I've got y times y for y squared. So just circle everything that you spy in both problems here. Here I spy a 5, and here I spy a y, and here I spy a y. So we just multiply 5 times y, and that's 5y squared. All right. So number 26 is D. All right. Moving on. Okay, so number 27, sketch the graph of the line. Okay, x equals 2. Remember, x is a vertical line. So I'm looking for a vertical line passing through 2, and that's right here. Okay, so number 27 is C. Y equals 2x. Okay, so we could say plus 0. So the y-intercept is 0 and the slope is 2 over 1. So I'm going to look for something that starts at 0 and then goes up 2 over 1. Here's one that starts at 0 and goes up 2 over 1. Right? This is a positive slope, so the answer is B. Number 29, y equals negative 1/3 x. Okay, so again, if you're not given the y-intercept, if it's not stated, you can assume it's 0. So we start at 0 and then we go down 1 and then 3 to the right. So start at 0, go down 1 over 1, 2, 3. That's this one here, B. 29 is B. Now here in number 30, we're actually given a proper slope and y-intercept. So the slope is negative 2 over 1 and the y-intercept is negative 1. So I'm starting at negative 1. And I'm going to go down 2 over 1. So we start at negative 1 on the y-axis, and then we go down 1, down 2, over 1, right? So you see this one, I started at negative 1. I went down 1, down 2, over 1 to the right. I'm back on my line, and that's how I know that it's B. 30 is B. Number 31, we're given the x-intercept and the y-intercept. Well, the x-intercept is at 4, 0. The y-intercept is at 0, negative 1. So I'm looking for a line that passes through negative 1 on the y-axis and 4 on the x-axis. That's C. Okay, number 32, y equals negative 2. That's just a straight line passing through negative 2. Okay, flat line, 0 slope. It's A. Number 33, we're given an equation in standard form, and we have to solve it out to be in slope-intercept form. So x plus 4y equals negative 16. Right, to get y by itself, we just subtract x from both sides. And now I've got 4y equals negative x minus 16. Divide each term by 4. Cancel, cancel. I got y equals negative x over 4 minus 16 divided by 4 is 4, so minus 4. Now this negative x over 4, we all know how to write that. That's negative 1/4 x minus 4. So I'm looking for a y-intercept at negative 4, and I'm going to go down 1 over 4. That's rise over run, fall over run. So it's a negative slope, so I'm looking for a downward pointing line. It's not B, because that's an upward pointing line. Don't even need to look at it. I need the y-intercept to be at negative 4, and here the y-intercept's not at -4. It's not that one. And over here, the y-intercept is not at -4, okay? That's the x-intercept right there, so it's not A. So let's check D. Do I start at -4? Yes. Do I go down 1 and over 4 to get to the next point? Down 1, okay, and that's going to be in the middle of those two lines, and then over 1, 2, pay attention to your scale, 3, 4, all right, because the scale's going over by 2. So it's D, all right. That was number 33. Now we're going to have to use the slope formula in numbers 34 and 35. Remember the slope formula, slope equals y2 minus y1 over x2 minus x1. So we just have to label x1, y1, x2, y2. So what we're going to plug into the calculator is 14 minus 4 over -10 minus 2. Alpha y equals enter. 14 minus 4 over -10 minus 2 gives me -5/6. It's C. Okay, in number 35, we're going to use the same formula. We just have to label x1, y1, x2, y2. Okay, so we're just going to plug in slope. Okay, this is our formula. y2 minus y1 over x2 minus x1. All right, so now I just have to identify that y2 is 20 minus y1 of 10 all over x2 is -13 minus x1, which is -8, so minus -8. Just plug the whole thing into the calculator. We've got 20 minus 10 on top over -13 minus -8 on the bottom. It's -2. Okay, numbers 34 and 35, C and B. Okay, number 36, we're finding the slope of each line. X plus 2y equals 0. You have to put this in slope-intercept form in order to get this. So we would subtract x from both sides. 2y equals -x. Now we'll divide both sides by 2. And doing it the way I just wrote it is exactly the same as putting a line under each thing. So on the left, the 2's cancel out, and I got y equals -x over 2. And we know that that equals -1/2 x. Okay, so this is my slope, -1/2, C. Number 37, I have x minus y equals -1. So I subtract x from both sides. The x's cancel, and I have -y equals -x minus 1. Go through, change all the signs, and I have y equals x plus 1. There's a 1 hiding in front of the x. The slope is 1. It's A. Now, in number 38, we have to actually, well, we could do one of two things. You could label each point and then use the slope formula. Okay, so I could label this at -1, 1, 2, 3, 4. So this is -1, 4, right? And that would be my x1, y1. And over here, I'm at 1, -1, 1, -1. And that's my x2, y2. All right. You could plug that into the slope, or you could just do rise over run. Start at one of the points and go down 1, 2, 3, 4, 5 over 1, 2. So I went down 5 over 2. That's the slope. -5 over 2. It's D. Number 39, I'll do the same thing. I'll start here and go up 1, 2, 3 over 1, 2, 3. So I rose 3 and ran 3. 3 over 3 reduces to 1, so the slope is 1. It's A. Okay, number 40, write the slope-intercept form of the equation of each line. Okay, So here we have to identify the slope and the y-intercept. Okay, so we need to know what the slope is and the y-intercept. Well, the y-intercept right here is at -4. And the slope, what we can do is look for a place where you can see those lines in the background crossing, and you use the y-intercept. Watch what I'm going to do here. Start at the y-intercept, go up 1, up 2, up 3, up 4, up 5, up 6, up 7, over 1. Okay, so I rose 7 and I ran 1, so the slope is 7. So if I want to write this equation in slope-intercept form, I just write y equals 7x minus 4. It's B. Number 41, same exact process. First we find the y-intercept, and then we figure out the slope. Okay, so my y-intercept here, we'll write slope, and we'll write y-int. My y-intercept is at -5. Okay, notice it goes down by 2 each time, so the ones in between are like -1, -3, and -5 here. They're not labeled, so you have to pay attention. Now we're going to do the same thing, all right? So what we need to find is another place where they cross. So they cross right here, so I can start here, okay? And I can go down 1, down 2, over 1. So what did I do? I went down 2 and ran 1. So the slope is -2. So y equals -2x minus 5. -2x minus 5 is A. Number 42, I'm still trying to write the slope-intercept form equation of the line. And all I have to do in this one is solve for y and arrange it so it looks like y equals mx plus b. Okay, so let's take our equation. X plus 3y equals -21. Subtract x from both sides. Now you've got 3y equals -x minus 21. Divide each term by 3. Okay, they cancel on the left. Now you have y equals -x over 3 minus 7, because 21 divided by 3 is 7. Well, that's equal to y equals -1/3 x minus 7. Okay, so that's it. It's A. 43, x minus 4y equals 0. Just subtract x from both sides. Trying to write, the reason it looks horrible the way I'm writing is I'm trying to write it so you can see it and I don't cover it up with my hand. So I got -4y equals -x. Okay, divide both sides by -4. Now you got y equals -x over -4. Negative over a negative cancels, makes positive. So I got y equals x over 4. All right, which can be written as y equals 1/4 x. So y equals 1/4 x is the answer. It's A. Okay, so now we have to write a slope-intercept form equation passing through the points given. Go up here and label them x1, y1, x2, y2. All right. Now we're going to be using the point slope formula, so we might want to write that. The point slope formula, I guess I'll do the work here, is y minus y1 equals m, open parentheses, x minus x1, close parentheses. So let's just stick in y minus y1, which is 3, equals m, which we don't know, open parentheses, x minus x1. Okay, so that's x minus x1, which is 3. All right, so now we've got this thing set up. All we have to do is plug in the slope. So let's calculate the slope. M equals y2 minus y1 over x2 minus x1. So we'll just plug in y2 is -1, y1 is 3. So -1 minus 3, and x2 is -5 minus x1 of 3. Okay, so stick this in the calculator if you don't want to do the math. Alpha y equals enter. -1 minus 3 over 5, -5 minus 3. And you get 1/2. So m equals 1/2. So now we're going to go plug 1/2 in for m. So I've got y minus 3 equals 1/2, open parentheses, x minus 3, close parentheses. We're going to distribute that 1/2, so we write y minus 3 equals 1/2 x minus 3 over 2. Add 3 to both sides. So you have y equals 1/2 x. And then you have to figure out what -3 over 2 plus 3 is. Again, if you don't want to think, you just do -3 over 2 plus 3 is 3 over 2. So plus 3 over 2. So it's y equals 1/2 x plus 3 over 2. Y equals 1/2 x plus 3 over 2. That's B. Number 45, same type of problem. Okay, let me separate this out. So we're going to label these points x1, y1, x2, y2. All right. We notice it's going to be passing through the origin. That's interesting. So it won't have a y-intercept like given. It'll just be y equals, sure enough, none of them have y-intercept. So let's first figure out the slope. I should have done it in that order in the last problem. Slope equals y2 minus y1 over, okay, x2 minus x1. Well, let's plug in what we've got. y2 is 0 minus y1, which is 3, over x2, which is 0, minus x1, which is -4. Okay, so that's the slope. If you don't want to think, plug it in. So we got 0 minus 3 over 0 minus -4. Enter. It's -3 over 4. All right, so we've got the slope. We've got m. Now we have to use the point slope formula. y2, oops, I was writing the slope formula. The point slope formula, darn it. That's y minus y1 equals m, open parentheses, x minus x1, close parentheses. All right, so y minus y1, where y1 is 3, equals m, which is -3 over 4, open parentheses, x minus x1, x1 is -4, so minus -4. These two minus signs come together and make a plus, and so we're just going to distribute that -3/4. So I've got -3/4 times x is -3/4 x, and -3/4 times 4 is -3. Okay, if you didn't want to do it in your head, that's -3 over 4 times 4, and you get -3. Okay, so now we just add 3 to both sides. Remember I said the y-intercept would be 0, so it's equal to -3/4 x, and this cancels, so it's y equals -3/4 x. So that's C. Okay, number 46. We have to find the missing length to the nearest tenth, and you're going to need to use the Pythagorean theorem to do these problems. Remember, the Pythagorean theorem says a squared plus b squared equals c squared. So we just have to figure out that we have to remember that c squared is always the hypotenuse. So this is c, and this is a, and we don't know b. All right? So we're going to write this out like this. 10 squared plus b squared, which we don't know, is equal to 11 squared. Okay? So that means 100 plus b squared is equal to 121. Subtract 100 from both sides. Okay? B squared equals 21. Okay? B squared equals 21. So now you have to take the square root of both sides, so b equals square root of 21. Second, x squared gives you the square root symbol. Square root of 21 is 4.58. If you round up to the nearest tenth, 4.58 is 4.6. So this is approximately equal to 4.6. Okay, it says round to the nearest tenth. So that's B. Okay, number 47. Remember that a squared plus b squared equals c squared. And c has to be the hypotenuse, so we don't know the hypotenuse. That's c, this is a, and this is b, right? So we know a and b. So we'll write 13 squared plus 9 squared equals c squared. Well, 13 squared is 169 plus 9 squared, which is 81. Of course, you could put this in the calculator. You could write 13 squared plus 9 squared. Okay, you'll get 250, and that's equal to c squared. So 250 equals c squared. Take the square root of both sides. C is going to be approximately equal to the square root of 250. Take the square root of 250, and you get 15.8 rounded to the nearest tenth. Okay, so the answer is B, 15.8. Number 48, Scott spent $24 on writing utensils. Pens cost 5 and pencils cost 1. Okay, if he bought a total of 8, then how many of each kind did he buy? This is a system of equations. Word problem, okay? These are kind of challenge problems. I'm telling you how to do them here in this review, so pay attention. All right, so we're going to write this. We're going to create a little. Chart. All right, we're going to fill it out. So first, let's identify what our variables are. Well, we have pens, which will pens and pencils. So we'll have to come up with something. Pens, we'll call pens. We're going to have to write it all out, and pencils. So here's the deal. I have something pens plus something pencils. Okay, and down here I've got something pens plus something pencils. All right, now we got to fill it out. Okay, so let's read. And by the way, these are both going to be set equal to some number. All right, so now you set this template up, and you're going to set the template up just like this in every problem. The process is to figure out what your variables are and then set the template up. All right, so you're always going to have a template that looks like this. All right, so Scott spent $24 total on pens and pencils. So all of it adds up to 24. He paid $5 for pens and $1 for pencils. So 5 pens, 5 times the number of pens he bought plus 1 times the number of pencils he bought equaled 24. So it says over here he bought a total of 8. That means that pens plus pencils equals 8. So you just put ones here. Now, what we have to figure out is what is the solution to this system of equations. And I'll show you 2 different ways to do it. Let me rewrite this, all right, where I'm going to use X for pens and Y for pencils. So I'm going to do this by hand, and then I'm going to show you how to do it on the calculator, okay? So first let me go over here and do it by hand. 5x, I'm just rewriting this. 5x plus 1y equaled 24. 1x plus 1y equals 8. Well, we can solve this using elimination, all right? We can solve this using elimination by subtraction and get rid of the y. So 5x minus 1x, that's 4x. These eliminate, equals 24 minus 8, that's 16. So 4x equals 16, x equals 16 divided by 4, so x equals 4. And now I just go plug 4 in for x. So instead of writing 1x plus 1y equals 8, I just write 4 plus y equals 8. All right, subtract 4 from both sides, and I get y equals 8 minus 4, which is 4. So the answer is he bought 4 pens and 4 pencils. It's B, okay? We know that, but I want to show you another way to do it on the calculator. If you're going to do it on the calculator, you have to memorize a series of steps. So here you need to thing you need to do is set up a little table with 2 rows and 3 columns. And you're just going to fill it in from the information that you're given in your little table that you already created. So the 5 from here goes right here. The 1 from here goes right here. The 24 goes right here. The 1 from here goes here. 1 here. 8 here. Okay, so you got this table set up. Now you go to your graphing calculator, turn it on, and what you're going to do is hit second and then this key that has the word matrix printed above it. Second x to the negative 1. So we call it second matrix. So now you go over to edit and then you hit enter. All right. So there's some data already in this. You just need to hit 2, enter, 3, enter, and you'll be looking at cleared tables, okay? You will be looking at cleared tables. What you'll see is that. So what you're going to enter is the data just as it's shown here. 5, enter, 1, enter, 24, enter, 1, enter, 1, enter, 8, enter. And you just enter all the data in, just like it appears in your little chart. Remember, it's got to be a 2 by 3 table, so you have to follow these exact steps. Now hit second mode to quit. Now hit second matrix, right arrow to math, and go down to RREF, which is the B value. Hit enter once, then hit second matrix, enter, enter. This top number right here is the pens, and the bottom number is the pencils. Put it another way, the top number is the X, the bottom number is the Y. So you get 4, 4. The solution to this system, by the way, is 4, 4. 4 pens, 4 pencils. That's how we get B on the calculator. Watch that again if you don't understand, but we're going to have another problem like that. So now we're on to number 49. There were 14 animals in the barn. Some are chickens and some are sheep. There are 36 legs in all. How many of each animal are there? Wow. This looks challenging. So there's 14 animals in the barn. Some are chickens and some are sheep. There are 36 legs in all. All right, so chickens have 2 legs, right? And sheep have 4 legs. So we can set up our thing here. We have chickens and sheep. This is kind of a silly problem, honestly. Okay, so something chickens plus something sheep equals something. And then down here I've got something chickens plus something sheep equals something. Okay, this is a little bit confusing on it. So there are 14 animals total in the barn. All right, so chicken plus sheep equal 14. So 1 chicken plus 1 sheep equals 14. Some are chickens and some are sheep. There are 36 legs in all. So chickens have 2 legs and sheep have 4 legs, and there's a total of 36 legs. All right, so how many of each animal are there? So if we're going to set up our table, we create a 3 column and 2 row table, so that's called a 2 by 3 matrix. Okay, so we have 1, 1, 14, 2, 4, 36. All right, if you're going to use the matrix method, let's do second plus 7, 1, 2 to clear all my memory out. If you're going to use this matrix method, which, you know, I highly recommend, I'll show you exactly what to do. Hit second matrix, right arrow, enter, and then hit 2, enter, 3, enter to build that 2 by 3 table, and then just type it all in. 1, enter, 1, enter, 14, enter, 2, enter, 4, enter, 36, enter. Now hit second quit, second matrix, right arrow once, down until you're on letter B, R, R, E, F, enter one time, then hit second matrix again, enter, enter. You get 10 and 4, so that would be 10 chickens and 4 sheep. So the solution was 10, 4. If you wanted to solve it using elimination, you would have to multiply the top equation by 2. So you'd have 1x plus 1y equals 14, and 2x plus 4y equals 36. You can't do this yet because you have to multiply through the top equation by 2, and now you'll have 2x plus 2y equals 28 over 2x plus 4y equals 36. So here I'm going to eliminate the x value by subtracting. Okay, so now I have 2y minus 4y is negative 2y. And then 28 minus 36 is negative 8. Divide both sides by negative 2. So y equals negative 8 over negative 2, which is positive 4. Y equals 4. So just plug y in as 4. You'll have x plus 4 equals 14. Subtract 4 on both sides. You have x equals 10. So x equals 10, y equals 4. 10, 4. The answer is A. Number 50. Find the area of each. Okay, well, the area of a triangle is just base times height divided by 2. Base times height divided by 2. Okay, and we just plug in the numbers that were given. So the base is given as 10.4, and the height is given as 9.9, and we divide by 2. All right, so just put this in the calculator. Alpha y equals enter. 10.4 times 9.9 over 2. It's 51.48. C. We are done. We completed a 50 problem test in 52 minutes. All right, so it took us just slightly, almost exactly 1 minute per problem. And actually, I want to give myself a little handicap here because I solved these two systems problems in 2 different ways. So if I'd only done it on the calculator, I could have shaved that off and been right at 1 minute per problem. So not a difficult test. I think you agree that there are some problems that are harder than others, and there are some that are just a joke, right, with the calculator. So here, the goal for today, which I think we achieved, was to get you guys ready for this Algebra 1 midterm, all right, with this little review here, and I think that we accomplished our goal. So with that in mind, guys, I want to thank you for your attention. And remember to like, comment, subscribe, and hit that notifications bell. Good luck on the exam. Thanks.